All right, let's get ready. And we're going live. We're super live. We are live for live stream number 106 in the Data on Kubernetes community. And it's the first time that we've ever done a live stream where someone has a virtual background as cool as Feynman and Zhou's. Anyway, Feynman is no stranger to our community. He is no stranger to the CNCF, super active in lots of organizations, in lots of events, and lots of communities. He's so involved that he was able to get a rap video of mine played at Kubernetes Community Days China. I'm super grateful for that. We're also joined by, and Feynman, when he's not organizing events, he's doing lots of stuff in KubeSphere, which we're going to hear more about as well. And we're also joined by Wei Gu. Very nice to have you with us. We met a while back, and we're finally getting this together. Very happy that it's happening. Finally. As usual, folks, if you've got questions, leave them in the chat on YouTube. We will get to them accordingly. I will let you take it over from here, gentlemen. Go for it.
Yeah. So let me share my desktop and give a brief introduction to myself and Wei. Okay.
Yeah.
Let me know if you can see my screen. Okay.
Yes, looks great.
Yes.
Hello, everyone. Glad to be here. I'm Feynman Zhou from Beijing. Now is the middle night in Beijing time, but I'm extremely enthusiastic about this session. And also you see my heart is very warm and hot. So go ahead. And my name is Feynman Zhou, and I'm CNCF ambassador and the community manager at KubeSphere. I have running this community for around two to 3 years. So, and Wei is my best friend from the Nebula Graph community. So Wei, you can give a brief introduction to yourself.
Thank you, Feynman. Thank you, Bart. It's my honor to have your time on DoK community and have sharing the same session with Feynman, the Feynman. And I'm an engineer from China, Shanghai, and I love open source, and I love Kubernetes and graph technology. That I hope I can help you out there. Yeah.
Yeah. Wei is an experienced developer advocate at Nebula Graph, and he's very good at the live demo. So he's gonna show you guys the live demo of running graph database. Yeah, the Nebula Graph on K3s with KubeSphere. And you can also running this graph database on Kubernetes as well. Okay, let's go ahead. In this session, we're gonna include some topics that ranging from KubeSphere, K3s, graph database like Nebula Graph, and we can learn and practice in a live demo. And next, we can show you how to install a live K3s cluster with OpenEBS installed in advance. Yeah, we will use KubeKey to install this cluster. And finally, we're gonna run Nebula Graph on K3s with KubeSphere and build the cloud-native observability for these database applications. Okay. First of all, I would like to give a brief walkthrough to the K3s. I assume you guys is totally familiar with the Kubernetes. Yeah. We say K8s, but K3s is a brand new distribution of Kubernetes. Yeah, we can say K3s is a lightweight Kubernetes. Its architecture is quite similar to the Kubernetes. You see there is the API server, kubeproxy, controller manager, and so on. Yeah, K3s also run the kubelet on their node. But the totally different point is that K3s didn't include the etcd. It has its own, we say, kind as is the backend store. Yeah. So K3s is very lightweight for running the Kubernetes services in Edge, IoT, continuous continuous CI and ARM, as well as the development scenario. So due to the lightweight characteristic, it only has the binary of less than 100 MBs. So K3s is totally lightweight for the edge and IoT use case. Yeah, let's go ahead to the next page. Yeah, let's take a look at the comparison of K3s and Kubernetes. As we mentioned earlier, K3s is totally used for the IoT and the edge use case. That is due to the K3s has removed two important things that built in the Kubernetes. Yeah, you know, K3s has out of three alternatives in the form of CSI and cloud controller in Kubernetes. So K3s has removed the in-tree storage drivers and in-tree cloud providers. Additionally, K3s simplifies the Kubernetes operations by maintaining functionalities such as it manages the TLS certificates of Kubernetes components. Okay, let's take a look at the challenges of adopting Kubernetes, or we say K3s in production. I guess you guys may know this series television, yeah, the Game of Thrones, and we see the White Walkers who tell us that we need security and we need to build the consistent logging pipeline. And yeah, we also hear a lot of complaints that Kubernetes or K3s is still complex, is still very complexity, and it is still hard to leverage this technology in our production. Yeah, even when we running the stateful workloads on Kubernetes, we still need to keep the reliability and high availability. Yeah, we see a lot of challenges when we really adopt the Kubernetes in production. Yeah, let's get a little bit deep dive into the challenges and the pain points when we adopt the Kubernetes in the production. Yeah, as we can see from the CNCF survey in 2020, we see that complexity has still occupied the highest item in those survey results. And we see the Kubernetes has the high learning curve, and it is very hard to bootstrap a high availability Kubernetes cluster, as well as the application lifecycle management, security and multi-tenancy, and so on. Yeah, we see a lot of pain points that we face in the production. Yeah, fortunately, we have a lot of open source solutions, and the CNCF ecosystem, you know, the CNCF landscape provides a wide range of the cloud native tools. Yeah, you know, the Kubernetes dashboard, Istio, Grafana, Prometheus, Helm chart. Yeah, a lot of open source cloud and the cloud native solutions have been included in the CNCF ecosystem. Yeah, in the past, we can leverage those tools and solutions to combine and to build our own platform as a service. Yeah, but in the real scenario, we see that we have different roles and teams in our company. Yeah, we have SRE, developers, testing, and you know, the architecture. And the different teams will own their different authorizations and access to different tools. That means we need to manage and operate different tools in different windows and different user interfaces. That will cause the high learning curve for end users and for different teams, since we need to manage the fine-grained access in different ways. We need to configure the access and the right management system for those different systems to connect with the Kubernetes. Yeah. So based on this background, we developed and open sourced KubeSphere. Well, KubeSphere is a distributed operating system for cloud-native application management. It uses Kubernetes as its kernel. So if we say Kubernetes is the Linux kernel in the cloud-native era, and we can say KubeSphere is the desktop, which is similar to the Ubuntu. Yeah, when we say KubeSphere is the desktop for the Kubernetes kernel, and KubeSphere provides a plug-and-play architecture, allowing third-party applications to be seamlessly integrated into its ecosystem. So we know if we installed a Ubuntu or Windows operating system, so it has a built-in application store that you can install any applications with one click. So KubeSphere has its own application store that you can install and operate any kinds of cloud-native applications within a single control plane. So far, KubeSphere has gained more than 8,000 GitHub stars and more than 1,000 forks in GitHub. So if you are interested in KubeSphere, you can go to the GitHub repository and install it via a couple of commands. So this is the general architecture of KubeSphere. KubeSphere provides service mesh, CI/CD, application management, observability, security, and authentication. Yeah, and it also brings you guys to the networking, load balancer, and some CNI management. So you can install KubeSphere in any kinds of infrastructures. So for example, you can use KubeSphere and install it on your bare metal, your own data center, your public cloud, or even the hosted or on-premises Kubernetes cluster. So KubeSphere is designed for the KubeSphere is an operating system that's designed for the distributed data center and public cloud. Yeah. This is the general architecture that includes the front end and the back end services. So the front end services will invoke the backend REST API and to implement the services while the KubeSphere KS API server, controller manager, and access control. So it has different backend services such as monitoring, alerting, security, storage, logging, and so on. This is the ecosystem that have been included and supported by KubeSphere, which ranges from application to the underlying orchestration and the database. Yeah, you can see it has supported Kubernetes and K3s. So you can also install those applications and operate those applications in a single unified management console. Let's go ahead and take a look at its roadmap. We started this project 3 years ago, and now we have released more than, in my memory, we have released 11 versions in GitHub. So you can take a look at those features and our ecosystem projects. So in the last month, we have published a huge milestone, which is the version 3.2. It brings GPU workload and GPU monitoring, as well as the multi-class scheduling in this version. So if you are interested in this version, you can take a look at our GA announcement. So most folks that are confused about the KubeSphere, and we see some guys that is KubeSphere a little bit heavy for us. So we would like to say that KubeSphere is pluggable and its components can be optional to install and uninstall. So you can enable any kinds of features and components that meet your needs. And we can say that KubeSphere is standing on the shoulder of a giant. Yeah. So the giant is Kubernetes, but we made a lot of enhancements and add-ons based on Kubernetes, such as the application lifecycle management, CI/CD, and service mesh. Since KubeSphere has provided the one-stop application lifecycle management and application store, yeah, this has never been included in the Kubernetes. As well as the CI/CD, KubeSphere integrates the Jenkins to provide the CI/CD pipeline, and it also integrates the STUI to provide the source to image for those developers that who are willing to build their own images in KubeSphere. As for the service mesh, KubeSphere integrates the Istio as its underlying service mesh framework. So you can leverage KubeSphere to build your own service mesh system and to add your own microservices, governance, and your topology based on KubeSphere. Yeah, this is the ecosystem that around KubeSphere. So we see a lot of pain points that we mentioned earlier. For example, if you want to expose your services in the on-premises clusters, especially for the bare metal cluster, you may have to try OpenELB. The formerly name is PortLB. And this project has been open source 2 years ago. And in the last month, this project, OpenELB, has been accepted by the CNCF Sandbox. And now OpenELB is a CNCF Sandbox project. So this project has addressed the service exposure in the on-premises environment. So you can use this project to expose your services with load balancer type of services in the bare metal cluster or the edge environment. The second example project is the Fluent-based operator. Yeah, this project is also accepted by the upstream community. Yeah, maybe you guys know the Fluent community. So Fluent-based operator facilitates the deployment and management of Fluent-based itself. And Fluent-based operator provides great flexibility in building logging layer based on Fluent-based. So you can leverage this project to build your own logging pipeline, and you can collect and gather your logs via this operator. And one another small tool that open source by our community is KubeKey. KubeKey is written in Go, and it is the next generation installer for Kubernetes and K3s and some cloud native add-ons. You can install it via a couple of commands, and it is quite easy to install and maintenance. KubeEye is also a brand new open source project which help you guys to find various problems on Kubernetes. It is a small diagnostic tool which helps you to find the unhealthy class components and the potential node problems. Yeah, the final project we open sourced this year is OpenFunction. OpenFunction is a cloud native open source fast platform. Yeah, as serverless is the serverless emerges in the cloud native ecosystem in these years, and we see this has been a new trend. If developers want to build their own function to the final image and publish them to the Kubernetes in an easy way. So OpenFunction can help developers to focus on their own business logics without worrying about the underlying runtime and the infrastructure. In this session, we're gonna focus on the installer KubeKey, and the graph database Nebula Graph. So this is the general workflow that if you want to distribute your application to different clouds that has multiple Kubernetes cluster. Yeah, this is a general screenshot of KubeSphere multi-cluster management. So it has imported the different multiple Kubernetes cluster in a single control plane. Typically in this session, we're gonna focus on the cloud native observability, which includes the logging, tracing, and monitoring. So in Wei's demo, he's gonna show you guys how to monitor and trace the logs for the pods and workloads of the Nebula Graph database. So yeah, this is the screenshot about the class status monitoring in KubeSphere, and this is the logging system of KubeSphere. So you can query different application logs while different dimensions. For example, you can query logs by namespace, pod, container, or some other dimensions. Yeah, this is the event console built in KubeSphere. So you can leverage this interface to trace and look back to your events of each pod. So yeah, as we mentioned earlier, KubeKey is a lightweight and easy to use installer for you guys to install K3s, Kubernetes, and OpenEBS within minutes. So it has only 3 commands. You can refer to this screenshot and copy paste it in your own terminal. So you guys can try it after our demo. And so I can, so Wei, I think you can prepare for your demo and continue to introduce the Nebula Graph and Graph database from your side.
Okay, thank you.
Great job, Feynman. Let's see it. Let's do it.
I will stop my sharing.
So can you see it?
Yes.
Yeah.
Looks good.
Okay, thank you.
And Wei, you may have to tell us about your rap experience that you told me about.
Yes, I'm an underground rapper. I make mixtapes in my garage when I was in middle school. Yes,
that's cool. That's super
Yeah.
cool. Anyway,
Genius.
we need to do a collaboration. Anyway,
okay, yeah,
but let's look at the demo first. Let's do the demo first, and then we.
Yes.
Yeah,
Yes,
this is
so
first time.
so actually, I'm wearing the hat of developer advocate of the Nebula Graph, and so Nebula Graph. I will give an introduction later, so you can reach me out from the GitHub, the Twitter, and my website. Yeah, so we will move on. I will start with what is. So we are talking about graph database. So what is graph, and what's a graph database? And why yet another database, right? We can actually start with a famous problem, which is called the 7-bridge problem, that back to 100 years before in the old Europe, in this old city, there are 2 rivers across the city, and the land will be divided by like 4 of them, and one of the guy raised the question that is it possible that we can traverse all the bridges, but we cannot repeat the traversing of the bridge, and we should walk through all the lands. So this is the famous 7-bridge problem, and underlying is actually a math problem that lead to the topology or graph theory. So when the guys trying to study this problem, they did some abstraction, so something similar to this, and finally to this. So what is here? So all the critical or the needed information here under this question are the dots and connections. So in graph, we name a graph. In the term of graph is constructed by the dots, the vertex, and the connection. We call it edges. So, and that's all about the graph. So, and now we know what is a graph, but what is a graph database? And literally, a graph database is some sort of system that is persisting the data in a graph way, right? But one thing I want to mention that is, other than the normal graph, in the graph database word, we use term property graph. That is the main things in term of graph, which is the nodes or the points or the vertex and the connections, the edges. And the third thing we added here is the property. Property is actually literally means the attributes or some key pairs in the nodes or in the vertex and the edges. So we will have some makes more sense in following demo slides. And the graph database is such a system to persistent those data in a graph way. And why do we actually need this, right? Can we just persist those information logically in tabular relational database? The answer is yes and no. Yes is we can logically map this information in a tabular table and with the schema like this. That is, for example, we have some table named person, another table named corporation. And when we want to describe there is a lag between the person to hold share another corporation or working as some role in another corporation. This is a lag actually. So we can actually, we have the table of the two entities, but we can create another helping or supplement table named hold sharing relationship table with link to both of the tables. So logically, you can describe or express your relationship or graphs information in a tabular database. That is doable, is feasible, but there is cost because the information was not natively persistent here. But when it comes to graph database, we can schema things just like this. It's quite straightforward, and there will be a reason why we need this in a straightforward way. So another perspective that why we need a graph database is graph database comes with graph semantic queries. So in this example, I put two equivalent queries based on different type of databases. And the meaning for this query is quite straightforward. It just, in graph database term, we call it one hop, one jump, one hook queries. So the meaning here is we query this data from one point over one kind of edges or relationships. And when we get the destination point, we start from that point to go another jump with another relationships. So in this case, we just search this basketball players, which team he had served, and we fetch all the other players that served as same teams. When we want to express it in a SQL way, in a tabular graph, non-graph database way, you will have to do something like this. So if you cannot see it clear, you don't need to. It's some kind of nested join. So this is just one hoop. But actually in the real world use case of graph database, you will have to do something like 5 or 10 hoops of queries. So it will be a curse or disaster for developer to write queries itself, right? But the last factor that I want to, which is a deal maker, that we actually need a database in natively supporting graph data is the performance. actually in some real world data volume or in multi-hop in a high concurrent query case, the difference, the response time, the throughput between the graph database and circle database could be in 1,000 times difference. So this is a deal maker when it comes to an online system, right? And in some other analytical use case, normally in sometimes you can actually make a query, you can get a response time in a human acceptable time period for graph database, but for non-graph database, you can get a result in like a couple of hours, which is quite unacceptable, right? So I assume that we agree that we need the graph database, but why do we need Nebula Graph, where it excels? So Nebula Graph, I will give a brief introduction. Actually, Nebula Graph was born in 2018, and it was designed with the initial purpose to addressing the case that we want to handle a huge volume of data, and it was initially designed in a distributed way. So, and it's open source from day one. And actually, till now, we are stepping to the version of 2.6, and a bunch of teams and even giant companies have chosen Nebula for the reason that it's one of the top graph database can handle their data scale or their needs, and it's also open sourced with a pretty active and healthy community. So yes, so you can actually after you can get the slides, you can reach out for more information from the two URLs. There are some architecture description and some successful stories shared by the user. And so we are talking about the data, the graph data running on top of the cloud or a container or Kubernetes. So for Nebula, we went for a typical evolution way. So initially, when the community is quite small and the team members, we don't have too much efforts or community contributors focusing on the cloud. So we just release a couple of Docker Compose files or even support a Docker Swarm. But lately, because almost everyone is using Kubernetes, so we like a year after, we have a Helm chart based deliverable of Nebula Graph. But as we know that Nebula is stateful, it's not best fitting with the Helm chart itself. So eventually we step to the cluster pattern, and we leverage the Kube Builder, set up our own Kubernetes operator. And I won't dive into details, but I will give a brief introduction of our implementation. And it's still in high speed evolving, and you can reach out to, it's also open sourced under Apache 2.0 here. And basically, we introduce some new CRD, so you can define the a whole cluster of graph database in one single file, like in 20 lines of YAMLs. And the controller of the operator will check the states and reconcile when needed, and it will communicate with the Nebula cluster itself rather than only the Kubernetes resources. This is the example of how it was done here, but I'm not going to dive into it. I will show you some real demos now. So I will switch to terminal. Yes. And before we dive into the actual live demos, I will give you some brief introduction on what's running actually on top of the Kubernetes. So this is the architecture picture, and in the left side here, it's actually the core part of the pure database of Nebula Graph. So you can see there are three types of workloads, and they are graph D, the meta D, and the storage D. And from this naming, we can guess that graph D is the one that handling the graph queries, which we can also call it the query engine or computation daemon. So it's the one that taking into the user's graph query, just like the one I showed you, go from something like that. And then it will make this query into the underlying storage queries, and it will call to the storage engine, which is the storage D cluster. It's consensus with the protocol of Raft. And when it fetch the needed information, it will make the needed computation in the graph D itself. We will review the detailed graph computation later in some following demos. And the meta D is literally maintaining the metadata for the graph database, including the authentication, the session management, and the data distribution, the data schema, etc. So it's also consensus with the Raft protocol. And the right side, I'm not going to explain in details. It's just a stateless workload. It's named Nebula Graph Studio, which is the GUI, is a graph data visualization tool. And from the top of the screen, we can see that with the help of the Nebula operator, we just abstract the whole cluster in quite straightforward CRD. I'm sorry, it's quite long. And you can see that, okay, I'm not going to show them all. And so we will go, we are moving on to the demo sooner. So before I will give introduction of my environment, that I'm actually running a KubeSphere flavored Kubernetes on a single server. And you can see after I install, actually with the kube key which was introduced by Feynman just now, I just gave one liner, which is quite straightforward and elegant. You will have a usable, a production level Kubernetes after boss together with all the components brought by the KubeSphere. And for example, this is the OpenEBS. It's quite usable for your test environment or edge deployment. You don't have a NAS or outside storage providers. It's quite useful for my demo because I don't need to install the host path provider myself. And so this is the output of the kube key, the KK one-liner install everything cluster tool, and we can see it come out of box with this KubeSphere beautiful dashboard console. So we can dive into what we have. Remember, I didn't show that in the console, but here. This is the kind of Nebula cluster, which is a CRD introduced by the Nebula Kubernetes operator. And you can see here from the CRD kind Nebula cluster, you will see that we only describe the workload in the spec like less than 100 lines. So you will have a proper maintained self-service Nebula Graph cluster, and the underlying is the data plane workloads is actually 3 stateful sets, which stands for the 3 components. Like this is storage D, and inside that we can see 3 replica because we specified replica in 3 now. Focus on this one, this part. You will see the container, and you can see the monitoring interface, which is beautiful. And you can, for example, dive into the container and see the logs. And also you can see the required corresponding the volume, the storage claim here, quite sweet. Also, this is the data plane of the cluster. We can also look into the control plane of the cluster. So there are actually 2 deployments. I'm not diving into them. So apart from that Nebula core part, which is the stateful part, core database, we also implement the Nebula Studio, remember, in the arc picture. And in the workload, they are just to actually in the default data, default namespace. It's just a deployment of the Nebula Studio. And you can see in this part, there are 3 containers here. And just as I shown in the picture. And now I will move more on the graph fields. So we will see what the Nebula Studio was defined, exposed pods is done by the service. It's a pure single service. We just use the node pod. So now we can back to the demo, and we will visit this Nebula Studio running on this cluster. So we will use the graph of the data set representing the basketball player and teams. So I will introduce, so this is the interface that we are manipulating and visualize the data in the graph format in the Nebula graph. So I will introduce you the data schema, like what we have in this graph. You remember the dots and the connections, right? The dots, there are 2 kinds of dots, which is player, which is the NBA players. You will know their name very famous later, and the famous NBA teams. And regarding the connections, the edges, there are 2 kinds. This is very simplified data module here. They are follow and serve. So follow refers to in the Twitter, you can follow another user. So this is one direction relationships. And serve means you serve, a player can serve a team in certain years or period. So we will explore the data now. So in the explore function, we will start with 2 of the dots of the nodes or vertices. We just randomly give some of them player. We give 2 points here. Right? They are shown. So I will. So when you click, you will see the properties here, and we want to show them in this GUI. Is in the show. We want to show the needed information that is friendly to our brain. So the data will be inspected here in a quite easy way for our brain to understand. We will give a different color, and we'll give this another color like blue. Yeah. So what we can do with this, with the graph database, so we can double click. Well, what does it mean? It means Tim Duncan follows Manu, and Tim Duncan also follows Tony, and Tim Duncan served in the Spurs in this year. So how about Yao Ming? Oh yeah, similar thing. So how about why there is no edges here? Oh, it's because, so this is the field that when we double click, it means expand. So we need to maybe consider incoming direction. Yeah, there is another. So how about Tracy? Yes. So this is the very typical connection between the 2 points, and now or typical use case in the graph database. So now we find that the random 2 selected players, they actually have some connections between them, each other. So the Yao Ming followed Shark O'Neal, and Shark followed Tim Duncan. So they are connected in some way, just like what we found in the social network like LinkedIn, right? Remember, it's a 1 degree shared. So how is it possible that we find all the connections between the two points? So the answer is yes, of course. And we can go with the algorithm of find path. So I will give the player ID here, player 133, and the relationship, the edges we don't feel it means all the relationship, and we give bi-direction of the expansion of find path directions. So this is the underlying query language that this visualizing tool is using. So it's the NGQL, which means the Nebula Graph Query Language. So it's quite straightforward. Just I'm not sure if you can see it clearly. I will read it out. Is find all paths from player 100, which is the Team Duncan, to player 133, which is Yao Ming, over star. The star is a wildcard referring to all kinds of relationships in the direction of bidirect. So let's click the expand here. Sorry. Okay, that's correct.
Can I just ask a question?
Yep, anytime.
This is amazing. Like this, well, that's a statement. That's not a question, but here's the question. Whose idea was it? Whose idea was it to use the basketball players?
Actually, it's a default data set in our documentation. It's quite easy.
Okay.
But I will give you this credit to Feynman because
good job, Feynman.
Yes. He's a basketball player. I know from his social network. And when I was preparing for this demo, I initially used another, boring examples.
This is very smart. This is very, very smart. And I think I hope you use this example in other live streams and fully take advantage of it, because it's always these things where we tell folks like Feynman did earlier as well, using White Walkers, using examples of things we can relate to from like our daily lives. I absolutely love it. So anyway, Feynman, I didn't know you were a basketball player either. I gotta pay more attention to your Twitter. Anyway, keep going. I'll be quiet.
Thank you.
I'm not a professional basketball player, but I play basketball many times. Yeah, I think. Yeah.
Nice. Yeah, no, I'm not a professional rapper. I just have the excuse to do it for the Data on Kubernetes community. Anyway, keep going. I love this. This is great.
By the way, I love your flow. Yeah. Okay, we will move on. And so why it looks cool, but why is it useful? Is there any use case in this scenario? The answer is obviously yes, but I will give you some example. So normally this kind of system can be also named as a knowledge graph, but maybe it's a single domain. It's only focusing on basketball players, but it's actually still a kind of sort of a knowledge graph. But what is a knowledge graph? I will give you an example. So when we Google something like Yao Ming, we can see results. So in the left side, basically, so we know Google is very complex, but basically it's just something similar to Elasticsearch. Just Google use a lot of spider bots to fetch all the data and assemble them in a certain way, and you search them. But in the right side, in this example, there are some cars with some more intelligence information here. So behind the scenes of this technology, there is knowledge graph. But I want to give you some more details examples. For example, we search for Yao Ming's wife age. And there is an answer that she is 40 years old. I'm sorry, I asked a girl's age here. But
just a number, it's just a number. It's okay.
Yeah, just number. And she looks beautiful and young. Yeah, but actually, you cannot do this with the sorted data in your Elasticsearch, something like that. So behind the scene, there'll be something more intelligent, and the majority of the technology behind this is the knowledge graph. And I will give you some more detailed examples now. So actually, I built a small intelligent query service like Siri, but I name it as Siri, SIWI, and I also implement this code in this demo environment I will show you now. So, and underlying is actually based on our Nebula graph. So I will make this query. So it's based on open function. So the first query will be slow because there is a cold start. So our question here is, who are Team Duncan's friends? And the answer is Team Duncan have followed two players, Tony Parker and Manu. So I prepared another question. So this is fast. How does Yao Ming and Lakers connected? So the answer is there are at least 19 relations between Yao Ming and Lakers. One path is something like that. So this is exact example how knowledge graph is applied to intelligent robot. So this is example here. And more than that, we can check what's underlying and running on our clusters. So we can see the workloads that we can see the pods, and the open function help us spawn a pod just now. And we can look into that in the function and in the container log. Yes, the two queries are underlying in the in the robot code. It will pass your question sentences, and it will do some categorize and intent matching. That your first query is you want to query friends, so intent is friend, and your entities and Tim Duncan. So my code will assemble this into a graph query, which is match to query your 1 degree friends. You can do it for n degree, like you have recommended in LinkedIn, right? And another one is one we already showed that is querying the connections between Yao Ming and Lakers. So intent here is the relationship, and it will make this query and return the result here. So it's a small, tiny use case. So the demo today will end now, but I will provide a more interesting demo in my next session in data on Kubernetes community. So that's it.
More Tim Duncan, more Yao Ming. Can we expect that?
Yes, exactly.
I want to be there. I'll be there. I mean, I will be there. I have the pleasure of having to be there. But
yeah,
this was
thank you.
This was super cool. Now I have a question for both of you. A frequent topic that we encounter in the data on Kubernetes community, which was mentioned by both of you, is the question of operators. In terms of what we see right now to make running data on Kubernetes easier, are operators the only solution you think we have, or can we expect further solutions in the future?
That's a good question.
Nobody has to go first. I just say that just because I say that because it's a frequent topic, and we've written about it in the new stack. We've had lots of conversations with different folks, but it's to see, okay, because for an organization, if they're going to build an operator, you need time, you need money, because time is money. People who are talented enough to do it. You have to make sure that those people who are building it will be in your company for long enough, because different operators take different amounts of time. So just asking the question, some people have said there could be one operator to rule them all. That seems pretty difficult because operators are so specific. But it's to see, do you imagine any other possible solutions to make this easier in the next year or two? Anything? There's no right or wrong answer,
well,
just your feeling.
Yeah. To me, that we already know that why we need an operator, robot operator is behind the scene is that we don't want to be caught in midnight. So in the loop that you want to you want to know that this one there is a CPU hype spike, or there are some dead disk found there, or there are some alarms there. So normally we're trying to avoid the human resource to get out being caught in midnight and handle everything. We want to automate or decouple the people in the operating circles. So to me, that if we're actually running them on top of Kubernetes, it's quite natural that because there are two parts of things that need to be handled by this operator, no matter it's a person operator or a Kubernetes operator.
Good point.
One is the resources regarding your container or other workload orchestrations. The other is the application itself. So operator is kind of fit perfectly that you can add your logic to reconcile both on the perspective of the Kubernetes resources and your workload logic. Like you need to rebalance on your application level. But it's my first time thinking about this question, and quite good question.
Yeah, and there's no right or wrong answer. There's no perfect answer. It's mostly just, you're working with this stuff. You're seeing this in your day-to-day. Now, I would like to take that question a little bit further to you, Feynman, is running data on Kubernetes a money problem, a technology problem, a knowledge problem, a people problem? We could say maybe it's a combination. What do you think is the biggest obstacle, the biggest challenge that's making it complicated for folks, for more people to run stateful workloads on Kubernetes? Tim Duncan is a possible answer.
I think we can say there's not a silver bullet for running stateful workloads on Kubernetes. Since for now we have the operator for to help us to resolve those questions, those issues that Wei mentioned before. Yeah, we have the operator to help us handle those automated operation and the maintenance works, and we don't need to wake up in the middle of the night. But we still have a lot of obstacles. We say that the data management, the data persistent issues. Yeah, but going forward, I guess that might be some new solutions for this barrier. Yeah, but I'm not sure if the next the solution will be come out and to solve this problem very well.
Yeah, that's why. No, go ahead. Go ahead. Sorry. Yeah.
Yeah. I'm not sure if customize or some other. I'm not sure you guys know Kuvela. Yeah, it's a new kind of application. We can say definition, and framework which help us to solve those kind of pain points.
Good stuff.
Yeah. Another point of view that I cannot come up with a technical solution, but we can manage to put the data on other guys' cluster, like you just use a managed database as a service, or even serverless. This year the thing that shocked me is the CRDB. They provide a serverless solution. You can scale down to 0, which is quite insightful for me. Yeah.
Serverless database service.
Yeah.
Right?
Yeah. So they will call the guys from the other company, not me. So.
Mm-hmm. Anyway, so we see different things happening, but this is also why we have a community so that people can get together, we can share these things. And oftentimes it's not about having the answers, it's about asking more questions and asking better questions. And so we understand this is very innovative. Many things are being done for the first time, but it's exciting to see the progress, and particularly recommendable to everybody. If you're taking notes during this presentation, on both sides, both of the speakers made a very, very big effort to make the material relatable. And I cannot thank you enough for doing that. Starting out with your presentation, Feynman, very easy to follow, very logical, very practical. And then the wonderful example of seeing a graph database, and also starting out with another database. Do we really need this? But we see the use cases. And once we start talking about Tim Duncan and Yao Ming, and even Yao Ming's wife, and her age, I had no idea she was 40. That's fine. Good for her. If Yao Ming's wife is watching this live stream, we salute you. We think you're a wonderful person. And we would be happy to have you as a guest. But I really, really think that's a great thing, is that in order for data on Kubernetes to be easier to understand, we need examples and presentations such as the one that you gave today to make it more tangible and not so scary. Let's see. Wei, I will ask you to stop sharing your screen so that I can share mine. No, it's okay. For everybody that was watching, these two gentlemen are very easy to find in social media, very active. So like I said, you can find them also in our Slack. You can find them in the CNCF Slack, very active on Twitter, also on LinkedIn. So please reach out if you have more questions about KubeSphere or about Nebula, and they will be happy to answer those. Wow, wait, you've got a lot of.
Sorry,
that's all good, man.
It's embarrassing. Sorry.
No, it's fine. It's fine. That's part of the magic.
At the bottom.
Yeah. You got to find the Zoom call.
You can find the stop sharing button at the bottom.
Bottom.
Yeah, he's right.
You can,
If not,
Okay.
I
I
may
will
have
kill
to,
it. I will
I-
kill it. See you later.
I may have to forcibly stop you
What?
from sharing your screen. Don't worry, man. This is the first time. This is we've done 106 live streams, and this is the first time.
I'm sorry.
No, it's all good. That's part
will
of the
come back.
fun. No, that's part of the fun. No, don't leave us. Don't leave us. You can find a way. How do I can stop your video, but I don't want to do that. I can make you an attendee, and then I can bring you back. Let's see. Or no, maybe that doesn't work. All
yes.
right, Wei, are you still with us?
Sorry?
Wei, are you still? Oh, no. Wei is now, he's been demoted to an attendee, and now you're gonna have to see my screen, which is totally crazy. Wei, are you there? Oh, no, oh, wow. He's also a hacker. He has multiple identities that he's using simultaneously. Okay, good. Can you see my screen?
Not yet.
Yep.
Not yet.
Okay.
Yeah, I can see it now.
Okay, but can you tell me what you see? Because you might see a lot of different things.
Yeah, this is
Beautiful.
a nice poster.
Okay, good. All right. So while you were talking, we had, as usual, our amazing artist, Angel, who's in the background. And I'm always talking to him while we're doing this. And he had a really good time today, too. He really enjoyed both of your presentations. So he got to have a lot of fun doing this. So anyway, a nice representation of some of the topics. There were quite a few topics covered. Very nice to get the White Walkers in there. And of course, the great basketball references. But I really enjoyed this. Looking forward to having you back, Wei, in 2022. Feynman, we'll get you back on too. We got to get you in our next KubeCon event too. By the way, if you want to apply for do a CFP for KubeCon, you have until December 17th. We'd love to see more data on Kubernetes proposals. We will, of course, also be having a co-located event in KubeCon in May for the Data on Kubernetes community, another DoK day. So you can look out for that. There are some folks also from our community who are right now in Las Vegas at reInvent. We hope they have a wonderful and safe time there. But anyway, that being said, like I said, both of our speakers are very easy to find, very knowledgeable, very friendly. So please feel free to reach out and interact with them whenever you get the chance. Gentlemen, it was a pleasure. Thank you both. Take care.
Thank you.
Yeah, thank you, Bart. Thanks for the
Bye-bye.
time.
My
Bye-bye.
pleasure.